Hi everyone, hope you are all well. So today we are going to study the classification of turbines. Okay, so we have two parameters to classify the turbines. One is the type of energy present at the inlet, and one is the direction of flow of water through the runner. And one parameter is the head available at the inlet of turbine, and one more parameter is the specific speed of the turbine. So on the basis of these three parameters, we classify the turbines. So first we are going to study the classification of turbines on the basis of direction of flow of water through the turbine or through the runner. Here, direction of flow of water through the runner. Okay, so I have kept it. I have drawn. I have drawn these figures. I have already kept them here. मैंने इनको पहले ही यहाँ पे बना के रखा है क्योंकि बिकॉज दे आर बिट कम्प्लेक्स तो दीज फिगर्स कंज्यूम टाइम सो I have already drawn them. Okay. So in this case, we have first type of turbine, that is tangential flow turbine. First turbine, on the basis of direction of flow of water through the runner, we have tangential flow turbine. In tangential flow turbine, water strikes the runner tangentially. This is the runner, and these are the vanes on the runner. Okay, water strikes the vanes tangentially. So when the water strikes the vanes tangentially, that turbine is known as tangential flow turbine. Okay, in this case we have an example of Pelton turbine. Pelton turbine is a tangential flow turbine that we are going to study in detail in next lectures. Okay, so second B category is B category is radial flow turbine. B is radial flow turbine. B1 is radial flow turbine. So I am going to rub this. This was the first category. That is tangential flow turbines. Okay. The next one is radial flow turbine. Next one is in this case radial flow turbine. Radial flow turbine. Okay. This is the design of radial flow turbine. Now here arises when a turbine is said to be a radial flow turbine when water enters the runner, when water flows through the runner radially in the radial direction. This is the radial direction. That means along the radius. When water flows through the runner along the radius, or we can say when water flows through the runner radially, so that type of turbine is known as radial flow turbine. In this we can write when water flows through the runner, radially. So this is known as radial flow turbine. In this case, we have in this category we have two types of cases. One is radially inwards and one is radially outwards. One category in this case is first category in this is inward radial flow turbine. Inward radial flow turbine. And one more category is outward radial flow turbine. Outward radial flow turbine. You can see here we have two wheels. One is this wheel and one is this wheel. In these two wheels, one is a guide wheel and one is runner. Among these two wheels, one wheel is guide wheel and one wheel is runner. If water flows radially inwards, that means if water flows in this direction, if water flows in this direction, that is radially inwards. So in that case, this outer wheel is known as guide wheel. This outer wheel is known as guide wheel, and this inner wheel, this inner wheel is known as runner. So when water flows radially inwards, this outer wheel is guide wheel and this inner wheel is runner. Okay, and next case is outward radial flow turbine. When the turbine is outward radial flow turbine, it means that water flows radially outwards. So in that case, in that case, in that case, this inner wheel, this inner wheel is a guide wheel. This inner wheel is a guide wheel, and this outer wheel, and this outer wheel is the runner. Okay. So when water flows radially inwards, then outer wheel is the guide wheel, which guides the water. What is the function of guide wheel? Guide wheel guides the water to the runner. Guide wheel guides the water to the runner. So outer wheel in this case is guide wheel in case of radially inward flow turbine, and this inner wheel is runner. Okay. So when water flows, when the turbine is outward radial flow turbine, that is when water flows out in the outward direction. So in that case, inner wheel is the guide wheel and outer wheel is the runner. Okay, so this is radial flow turbine, and in radial flow turbine we have two examples. One example is, sorry, we have only one example that we study. We have only one example that we study in this chapter, in the chapter of turbines, that is Francis turbine. Francis turbine is a radial flow turbine. Okay. Now we have one more category in this classification, that is axial flow turbine. That is axial flow turbine. Next type of turbine, C category in this case is axial flow turbine. Okay. Guide wheels, runners, Pelton turbines, Francis turbines, and axial flow turbines. We are going to study them one by one in detail in the next lectures. Okay. So this is axial flow turbine. Axial flow turbine, when water flows through the runner parallel to the axis of the runner, when water flows through the runner parallel to the axis of the runner, so that type of turbine is known as axial flow turbine. I will show you here. Okay, this is known as boss. This is the axis of the turbine. This is the axis of the turbine. This is the axis of the turbine. These are runner vanes. These are vanes. These are vanes, and this is known as boss. This is known as boss, and this is the axis of the turbine. So in this turbine, water flows through the runner parallel to the axis of the turbine. This is the axis of the turbine, and the direction of water flow is like this. 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 So when the direction of flow through the turbine is parallel to the axis of the turbine, that turbine is known as axial flow turbine. That type of turbine is known as axial flow turbine. That is direction of flow, direction of flow, direction of flow of water, direction of flow of water through the runner. Through the runner is parallel to the axis of the runner, is parallel to the axis of the runner. These are runner blades. This whole part is a runner. These are runner blades. So in this case, water flows parallel to the axis of the turbine. Therefore, this is known as axial flow turbine. In axial flow turbine, we have an example of Kaplan turbine. Kaplan turbine is an example of axial flow turbine. In Kaplan turbine, water flows parallel to the axis of turbine through the runner, which we are going to study in detail in next chapters, next lectures. Okay, this is C category, and D category with us is mixed flow turbine. In this classification, D category we have that is mixed flow turbine. That is mixed flow turbine. So in case of mixed flow turbine, water flows through the runner in the radial direction, and water leaves the runner in the direction parallel to the axis of runner. So that is known as mixed flow turbine. So we will write the definition here. When the water flows through the runner in a radial direction. When the water flows through the runner in radial direction and leaves the runner and relieves the runner in the direction parallel to the axis of turbine. Parallel to the axis of the turbine, then the turbine is known as mixed flow turbine. Through the runner, water flows in the radial direction, and when water leaves the runner, it leaves in the direction parallel to the axis of the runner. So that this turbine is known as mixed flow turbine. In this case, we have an example of modern Francis turbine is an example of mixed flow turbine. So this was the first classification based on the direction of flow of water through the run. Then we have next. We have next classification. Next classification is based on the type of head present at the inlet of the turbine. Type of head present at the inlet of the turbine. Sorry, type of energy. This is type of energy present at the inlet of the turbine. So this is the next classification. In this case, we have two types of turbines. one is impulse turbine. One category is impulse turbine. Okay, and next category in this case is reaction turbine. Reaction turbine. Type of energy present at the inlet of the turbine. When the type of energy present at the inlet of turbine is kinetic energy, is only kinetic energy. That is the jet striking the vanes of the turbine has only kinetic energy. So that turbine is known as impulse turbine. And in this case, we have an example of Pelton turbine that we are going to study later on. And in case of reaction turbine, in case of the reaction turbine, the energy present at inlet of the turbine is kinetic energy and pressure energy. Okay, and during and during and during the flow of water, and during the flow of water, during the flow of water through the turbine, during the flow of water through the runner, through the runner, some part of some part of some part of pressure energy converted gets converted into kinetic energy. Okay. This type of turbine is known as reaction turbine. In reaction turbine, the head present at inlet is kinetic energy, and the type of energy present at inlet of the turbine is kinetic energy and pressure energy. And upon flow through the turbine, some part of pressure energy is converted into kinetic energy, and this type of turbine is known as reaction turbine. In reaction turbine, we have two examples which are going to study later. That is Francis turbine. That is Francis turbine. That is Francis turbine, and one more is Kaplan turbine. So this is the classification based on the type of energy present at the inlet of turbine. Okay. So after this, we have one more classification that is based on the head available at inlet of the turbine. Third classification is head present at the inlet head present at the inlet of the turbine, head present at the inlet of the turbine. Okay, so based on this parameter, we have three types of turbines. One is high head turbine. High head turbine. Okay. B1 is medium head turbine. Medium head turbine. And C1 is low head turbine. Low head turbine. Okay. We know grass head, we know head law due to friction, and then we know the difference of grass head and difference of head law due to friction, that is net head. So that means when net head at the inlet of turbine is high, that is known as high head turbine. When it is medium, that is known as medium head turbine, and when it is low, it is known as low head turbine. So high head means the head will be 250 to 1000 meter. Okay, if the head is between 250 and 1000 meter, so that turbine is known as high head turbine. And if the head is between 60 meter to 150 meter, if the head is between 60 meter and 150 meter, that is known as high head turbine. That is known as medium head turbine. And if if the head is less than 30 meter, if the head is less than 30 meter, that is known as low head turbine. In case of high head turbine, we have an example Pelton turbine. Pelton turbine is the example of high head turbine, and and Francis turbine. Francis turbine is the example of medium head turbine, and one is low head turbine. In low head case, we have Kaplan turbine. Okay. So if the head is high, that is 250 between 250 meter and from 250 meter to 1000 meter, that turbine is Pelton turbine. And if the head is from 60 meter to 150 meter, that is Francis. And if the head is less than 30 meter, so that type of turbine is Kaplan turbine. Okay. So another classification that is based on the specific speed of the turbine. Fourth and the last classification. The fourth and last classification that is based that is based on the specific speed of the turbine. Specific speed of the turbine, and the specific speed we represented by ns. We are going to study it later in detail, but for now, just remember, on the base of specific speed of the turbine, we have three types of turbines. One is high specific speed turbine. High specific speed turbine. Okay. So next one is medium specific speed turbine, and third one is low specific speed turbine. Low specific speed turbine. The specific speed we will later study in detail. So for now, high specific speed turbine. For this case, we have specific speed from 300 rpm to 1000 rpm. Okay, so this is high specific speed turbine. If specific speed is from 300 to 1000 rpm, so this turbine is known as high specific speed turbine. For medium specific speed, we have 60 rpm to 300 rpm. Okay. For medium specific speed turbine, we have head varying from 60 to 300 rpm, and for low specific speed turbine, we have head less than 35 rpm for single jet turbine. For single jet turbine, we have specific speed less than 35 rpm. If for single jet turbine specific speed is less than 35 rpm, then the turbine is low specific speed turbine. And in case of multi-jet turbines, specific speed is from 30 rpm to 60 rpm. In case of low specific speed turbines, and in case of multi-jet turbines, single jet, when only single jet is striking the vane of the turbine. The when more than one jets are striking the vane of the turbine, so that is known as multi-jet turbines. For multi-jet turbines to be low specific speed is from 30 to 60 rpm. So this was the classification of the turbines. four important classifications based on four important parameters. First is direction of flow through the runner of the turbine. Second is type of energy present at the inlet of turbine, and third one is head on the turbine, head available at the inlet of turbine, and last one is specific speed of the turbine. On these four parameters, we classify the turbines. Okay, so these four classifications are important classification, and this data is important, which I have written in case of specific speed and in case of head level battery inlet of turbine. So this data is important. Okay, in this case we have an example of, in this case the example is Kaplan turbine. Kaplan turbine is the high specific speed turbine. Okay, and Francis turbine and Francis turbine is the medium specific speed turbine, and Pelton turbine. Pelton turbine. Pelton turbine is the low specific speed turbine. Okay, so this is the data. These are the examples which we need to remember. Okay, so this was all about the classification of turbines. Later on in the next lectures, we are going to study Pelton turbine, Francis turbine, and Kaplan turbine in detail, inshallah. So that is all for now. Thank you.